U.S. Air Force is preparing for a substantial technical critical design review of its next-generation B-21 Raider bomber, an aircraft said by developers to mark a new generation in stealth technology able to elude the most advanced air defenses in the world. The review, described by Air Force officials as a key step prior to formal construction of the aircraft, will assess design specs, technology plans, computing power and weapons integration for the new bomber, a platform which service developers say will advance stealth technology itself to new, unprecedented dimensions of technological sophistication. The B-21 program has completed preliminary design review. The next step is critical design review. The Air Force remains confident in the B-21's progress and in delivering this new capability as planned in the mid-2020s, Senior Air Force Public Affairs Director Anne Stefanek told Warrior Maven. Critical reviews of the emerging B-21 design are essential to engineering a platform able to accommodate the most advanced current and anticipated future stealth properties, which include stealth coding and configuration, radar cross-section reduction and heat signature suppression technologies, among other things. A new generation of stealth technology is being pursued with a sense of urgency, in light of rapid global modernization of new Russian and Chinese-built air defense technologies, advances in computer processing, digital networking technology and targeting systems now enable air defenses to detect even stealth aircraft with much greater effectiveness. Russian-built S-300 and S-400 air defense weapons, believed by many to be among the best in the world, are able to use digital technology to network nodes to one another to pass tracking and targeting data across wide swaths of terrain. New air defenses also use advanced command and control technology to detect aircrafts across a much wider spectrum of frequencies than previous systems could. This technical trend has ignited global debates about whether stealth technology itself could become obsolete. Not so fast, says a recent Mitchell Institute essay, The Imperative for Stealth, which makes a lengthy case for a continued need for advanced stealth platforms. The essay's principal claim, fortified by lengthy analysis, offers a window of substantial detail into comments from Air Force senior leaders that the B-21 will advance stealth technology such that it will be able to hold any targeted risk, anywhere in the world, anytime. Stealth technology works by engineering an aircraft with external contours and heat signatures designed to elude detection from enemy radar systems. The absence of defined edges, noticeable heat emissions, weapons hanging on pylons or other easily detectable aircraft features, means that radar pings can have trouble receiving a return electromagnetic signal allowing them to identify an approaching bomber. Since the speed of light, electricity, is known, and the time of travel of electromagnetic signals can be determined as well, computer algorithms are then able to determine the precise distance of an enemy object. However, when it comes to stealth aircraft, the return signal may be either non-existent or of an entirely different character than that of an actual aircraft. A stealth aircraft will, for instance, appear in the shape of a bird or insect to enemy radar. Given the increased threat envelope created by cutting-edge air defenses, and the acknowledgement that stealth aircraft are indeed much more vulnerable than when they first emerged, Air Force developers are increasingly viewing stealth capacity as something which includes a variety of key parameters. This includes not only stealth configuration, IR suppression and radar evading materials but also other important elements such as electronic warfare jamming defenses, operating during adverse weather conditions to lower the acoustic signature and conducting attacks in tandem with other less stealthy aircraft likely to command attention from enemy air defense systems. Given these factors, Air Force developers often refer to stealth configuration itself as merely one arrow in the quiver of approaches needed to defeat modern air defenses. Mixing stealthy aircraft with conventional aircraft, deception, air defense suppression, and electronic jamming will complicate an enemy's defensive problem set by an order of magnitude, the paper writes. The authors of the paper explain that newer stealth technology able to outmatch advanced multi-frequency air defenses must utilize a characteristic known as broadband stealth, multiband or broadband stealth, which is designed to elude both lower-frequency area surveillance radar as well as high-frequency engagement radar, puts an emphasis upon radar cross-section reducing tailless designs such as that now being envisioned for the B-21. The B-21 image released by the USAF depicts a design that does not use vertical flight control surfaces like tails. Without vertical surfaces to reflect radar from side aspects, the new bomber will have an RCS, radar cross-section that reduces returns not only from the front and rear but also from the sides, making detection from any angle a challenge, the Mitchell Institute writes. Stealth fighter jets, such as the F-22 and F-35, have an entirely different configuration and rely upon some vertical flight control surfaces such as tails and wings. Being more vulnerable to lower-frequency surveillance radars due to having a fighter jet configuration, an F-35 or F-22 would depend upon its speed, maneuverability and air-to-air attack systems to fully defend against enemies. Given that fighter jets require tails, wings and other structures necessary to performance, they are naturally inherently less stealthy than a high-altitude bomber. Newer methods of IR or thermal signature reduction are connected to engine and exhaust placement. Internally configured engines, coupled with exhaust pipes on the top of an aircraft can massively lower the heat emissions from an aircraft, such as the structure of the current B-2, the authors of the essay say. Hot gases from the engine can be further cooled using mixing techniques in the exhaust system, the paper writes. Technical progress in the area of advanced computer simulations are providing developers with an unprecedented advantage in designing the new bomber as well. Simulations of interactions between designs and various threat radars are now far more accurate and realistic, allowing additional refinement of stealth design solutions before any hardware is actually built or tested, the essay writes. The new aircraft will be designed to have global reach, in part by incorporating a large arsenal of long-range weapons. The B-21 is being engineered to carry existing weapons as well as nuclear bombs and emerging and future weapons, Air Force officials explained. If its arsenal is anything like the B-2, it will likely have an ability to drop a range of nuclear weapons, GPS-guided joint direct attack munitions and possibly even the new Air Force nuclear-armed cruise missile now in development called the LRSO, Long-Range Standoff Weapon. It is also conceivable, according to Air Force developers, that the new bomber will one day be armed with yet-to-be-seen weapons technology.